Alright, so here we are with the 3-5 assignment. It says that we need to find the exact solution algebraically and check it by substituting into the original equation. I, P.S., am not going to substitute it back in, but officially on quizzes, tests, I would recommend it, because otherwise, you probably missed a step. It's a test. People get nervous. Okay, so on that, the first one here, we are given that 36 is being multiplied by 1/3 to the x over 5. Sweet. Well, 36 is being multiplied, so let's go ahead and actually divide that before we do anything fancy. So 4 divided by 36 is what we want. So 4 divided by 36 is 0.1 repeating, or 1/9, which I'm going to write as 1/9 instead. It'll help us out later, I'm sure. And then 1/3, that's being brought to the x over 5. Okay, so of course now we're going to want to rewrite this 1/9 as something with a 3. So if we rewrite it, we've got 1/3. You know what, maybe we don't have to. Yeah, let's not. Let's just do rewriting it from exponentials to logs. So we can rewrite this as log base 1/3 of 1/9. There we go, we don't really need to have that. And that's equal to x over 5. Well, it turns out this first thing is a decimal, so let's find that. And so that value is, 2. How nice is that? Okay, and that equals x over 5. And so to solve, we'll multiply by 5, and we get 10. So again, if you wanted to, you can go back in, plug in a 10 right here, and realize that apparently that's going to be 4. Alright. Okay, so moving on, it's almost the same exact problem, so let's go ahead and divide by the number that's out front, in this case 32. So 1/4 with an x over 3 as the power is going to equal 2 over 32, which is technically 1/16. And then if we take this exponential and write it in log format, we're going to have log base 1/4 of 1/16 equals x over 3. And again, that becomes a decimal. So, and how awesome is that? It also is 2, and so 2 is going to equal our x over 3, but we need to multiply by that denominator and get an x equal to 6. Alright, the next one is kind of the same idea. Again, we're going to divide out something first. So we'll have 5x over 4 equals half of 250, which is 125. Then we can rewrite this in log format. So log base 5 of 125 is going to equal x over 4. We can get this as a decimal, or the number 3, and so 3 is going to equal x over 4, or multiplying by 4 makes x 12. Alright, so lots of fun algebra here. Okay, same steps on the next one. Divide by that multiplier so we can get our exponent all by itself. So 4 to the x over 2 equals 96 over 3. Alright, okay. We're recording with Logan in the room, so we'll see how that goes. If we rewrite it with our logs, we're going to have log base 4 of 32, which is going to equal x over 2. Evaluating this as a decimal, and so that decimal is 2.5, which we will end up multiplying by 2 to both sides and get an x of 5. Alright. Next one is a multiplier again of 2, so we'll divide that out and get 10 to the negative x over 3 equal to 10. Wow, lots of 10s. So I'm going to skip a moment here and not talk about logs because this exponent is going to equal that exponent. So negative x over 3 equals 1. Hopefully we all know that if we write a negative in our fraction, so the negative, it's kind of in the numerator in how I wrote it, but it could be in the denominator as well. So either way, we could multiply by a negative 3 to both sides in order to solve, which will cancel the negative, leave us with an x of negative 3. All right. So, then moving on to number 6. Wow, how many of these do we need to do? It's all good. Practice is lovely. So, 5 to the negative x over 4 is going to equal 5. And just as we did in the previous problem, that means that that exponent of x over negative 4 is going to equal 1, which we can multiply both sides by negative 4 to cancel the 4's and give us negative 4 as the answer. Alright, now we've got some logs, so we're probably going to rewrite them as exponents in order to solve. So in this one, 10 is going to be brought to the 4, which will equal x. So that just means a 1 with 4 zeros after it is your x. Alright, next one, we've got 2 to the 5th as our rewriting is going to equal x, and 2 to the 5th is 32. Alright, and the next one, using exponents again, 4 to the negative 1 is going to equal x minus 5. 4 to the negative 1 is 0.25, and so we'll just add a 5 to both sides, and our answer is 5.25. The last example is kind of the same here, but it's 4 to the 1 is going to equal 1 minus x, again rewriting from log format to exponential format. And so in that case, we need to subtract a 1 from the 4, and that's going to equal negative x. Be careful not to drop your negative there. And so then we need to divide by that negative 1 that would be there, and so x is negative 3. Alright, next ones, they want you to solve each equation algebraically, super, and obtain a numerical approximation for our solution. Again, check by plugging it back in, which is a great technique when we are doing something other than a homework assignment where you can check your answer by the answer key. So, either way, this first one here is written in exponential format, so we're going to want to rewrite it as logarithmic format. And so as you can see now, we do in fact have something that you can just put into your calculator and get a decimal approximation for. So we'll type that in, and you end up with 24.2151, or however many decimals you feel is appropriate, since it doesn't say in the problem. Usually an answer, I always just do 4 decimals, but potentially 2 could be acceptable, but anytime that you're in the middle of a problem, definitely want to keep as many as possible. So I just go with 4, and then we're all safe. So next piece here, again, it's in exponential format, so if we write it as log base 0.98 of 1.6, that's going to be what we plug into our calculator and get a decimal. And so our result is negative 23.2644. Alright, moving on to the next, we have some exponentials, some e's. Either way, we have a multiplier, so we're going to divide out that 50 first and get e to the 0.035x equal to 4. Then we're going to need to rewrite this, but with natural log, of course, because of the e. So natural log, because it's base e of 4, is supposed to equal 0.035x. But of course that's multiplied, so if we just take 0.035, divide it to both sides, we're going to get an x of whatever natural log of 4 is, divided by 0.035. And so that gets us a decimal of 39 point, and since I wrote too big, 61. There we go. Alright, same process for the next one. We're going to divide by that 80 that's out front, because of order of operations. We'd have multiplied after we do the exponent. So to solve, we've got to do it backwards first. So 3 is 240 divided by 80, and then we are left with our e to the 0.045x. Again, rewriting with natural log, because it's base e of 3 is going to be 0.045x. So we'll divide by that 0.045. And we end up with an evaluating natural log of 3 divided by 0.045, which makes an x of 24.4136. Alright, whoops, moving on. There. Now we have something added or subtracted, so either way we're going to subtract a 3 to both sides of the equation. Now we have 2e to the negative x equals 3, because I can subtract. There we go. And then, oh my gosh, there's a multiplier, so now we divide. And we're left with e to the negative x equals 3/2, which is 1.5. Then it's in exponential form, so let's rewrite it with natural log base e of 1.5 equals negative x, meaning that whatever we get as our result, we'll divide by negative 1, and that will be our x. So natural log of 1.5 divided by negative 1 is leaving us with negative 0.4055 if you round. Alright, same thing on the next one, only there's a negative 3 out front, so we'll end up dividing by a negative number. It's all good, so negative 5 is going to equal our negative 3e to the negative x. Divide both sides by that negative 3, and we'll result with e to the negative x equals 5/3, so 1.6 repeating, so I'll just keep that as 5/3. Then we rewrite with natural log, so base e of 5/3, and again natural log because it already has a base e. So if you didn't use natural log, you'd have written log base e, and hopefully you'd realize that that just means natural log. And then that is going to equal negative x, so just like the previous, if we end up then dividing by negative 1, we'll get our actual x value. So natural log of 5/3 divided by negative 1. So opposite. Alright, negative 0.5108 is our result. And then our last few here. Now instead of having the number out front, we have it out back. Whatever. So subtract 4. You're left with 3 natural log of x minus 3 equals negative 1. Oops, positive 1. Then we divide by 3, boop, and we get natural log of x minus 3 equal to 1/3. Now it's already written in log format, so we're going to take the time to write it in exponential format, so e to the 1/3 is going to equal x minus 3. And so in order to solve, we need to rewrite, we need to actually get the decimal of e to the 1/3, which is gross, so 1.3956, and that equals x minus 3, so let's add a 3 to both sides. So it turns out 4.3956 is our x value. Hopefully we have enough room for the next one. Let's see. So this first one here, we're going to subtract a 3. If we subtract a 3, we have negative log of x plus 2 equals 2. Then we need to divide by a negative 1 that's out front, so we'll divide by negative 1 and get a log x plus 2 equals negative 2. Rewriting with our base of 10, we get 10 to the negative 2 is going to equal x plus 2. So 10 to the negative 2 is 0.002. 10 to the negative 2. Oh, no, sorry. 0.01. Okay. Either way, x plus 2, and so we'd subtract 2 to both sides, and Lord, we'd have negative 1.99 as our x. Gonna squeeze that in there. Sweet. Alright, so the next ones we need to solve by the method of our choice. Excellent. And we're going to support our solution by a second method. No, I'm not going to be doing that. Okay. So solve each equation by the method of my choice. Alright. So this is written in log, so it's always good to say, well, if it's log, then let's try writing it exponentially. So in this case, 10 to the 6 is going to equal x squared, so I just need to know what 10 to the 6 is, which is 1 with 6 zeros after it. 1, 2, 3, 4, 5, 6. Boop. And so then in order to solve for x squared, we would undo that squared. And we would get, apparently, 1,000. Woohoo! So 1,000 is our x. Again, you could solve that via another method. I suppose you could take everything at the beginning and raise it from a 10. And then literally you'd have this same line after that. So, wow. Either way. Alright, so the next one is log base e. So if we rewrite as exponential, we have e to the fourth equals x squared. E to the fourth is actually 54.5982. But if that's equal to x squared, let's square root it so we can actually find out that x is equal to 7.3891. Woohoo! Alright, moving on. Next one's here. Woo! Alright, we've got some halves and some, lots of stuff. Okay, so first of all, this half is not helping. Oh, yeah, lots of happening. Okay, so I'm going to bring that half up. So then we'll have natural log of a half, which is technically a square root, of x plus 3. So again, I could have written this as x plus 3 to the half, but to me that just is hard to grasp versus a square root. Then at the same time, I'm going to add this natural log of x over to the other side, and so now I have natural log of x equal to natural log of that. Now if we understand how we solve equations, if I have a natural log of one side and a natural log of the other side, I can undo those natural logs. Either way, I can take e to it and e to the next one, which will cancel the natural logs, and leaves us with a square root of x plus 3 equals x. So, how do we solve this? Well, let's undo the fact that there is a square root by squaring. And so x plus 3 is going to equal x squared. And then anytime you have an x squared and some other variables, you do have to then rewrite it so that you can solve with it equal to 0. So x squared minus x minus 3. So, since that's not factorable, boo, we're going to have to solve with the quadratic equation, which I'm going to do on another page. Alright, so from our equation, a is going to equal 1, and b is going to equal negative 1, and c is negative 3. Yep, because there's a 1 here, negative 1, negative 3. So we'll go ahead and plug it into our equation. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And if we plug it in, that means we have a negative 1 that we will add and subtract the square root of another negative 1 squared minus 4 times a, which is 1, times b, which is negative 3. And that's going to be over 2 times a, which is 1 again. Alright, so simplifying, that means we have a 1 plus or minus 1 plus 12 over 2. So this is 1, that's negative times negative, so positive 12. And so our answers are going to be this disgusting set of numbers. So apparently x is going to be 1 plus the square root of 13 divided by 2, which is 2.3028. And also 1 minus the square root of 13. That result divided by 2 makes negative 1.3028. Alright, so going back here, our x's then are both of these numbers, negative 2.61 and negative 1.30. Gross. Okay, so then we're going to do our next one, which literally looks like it's going to be the same terribleness. So we're going to go ahead and bring this exponent in. So we have log of x minus log of x plus 4 square root of of x plus 4, and that's going to equal 1. Alright, so this one's a little different than the last one because I can't move over the log and not have that 1 there. So instead I'm going to write this as 1 logarithm because that subtraction means division. So log of x over the square root of x plus 4 is going to equal 1. Which means we can rewrite this. This is base 10, so 10 to the 1 is going to equal x over the square root of x plus 4. Alright, so this is a dream. Alright, so let's go ahead and, I had to write it on another page because there's so much. Okay. So, I'm going to multiply both sides by x plus 4 because denominators with a variable are disgusting. So, 10 times the square root of x plus 4 is going to equal x. Okay. Then, because we can't really have a square root in order to solve, we're going to square both sides. And so if we square both sides, we end up with 100 times x plus 4. So distributing that, we're going to get 100x plus 400, and that's going to equal x squared. Which to solve means that I'm going to subtract 100x over and 400 over to get 0 equals x squared minus 100x plus 400. Alright, I do not believe that there is a multiple of 400 that then adds to be negative 100, so we're just going to use the quadratic equation again. Our a value is going to be 1, our b value is negative 100, and our c value is negative 400. I lost my negative there. Alright. So x is going to equal negative b, which is 100, plus or minus the square root of b squared, so 100 times 100, whoa, which is 1 with 4 zeros behind it, minus 4 times a times c, so 4 times a times c just means 4 times 400, so plus 1600, all over 2a, so just 2. So that means that we're going to have 100 plus or minus the square root of this terrible number. 123 plus 160. So, plus or minus the square root of 11600. Alright, so what is the square root of that? A decimal. So, instead we'll just say that x is equal to 100 plus that number divided by 2, which makes 103.8516. And x is also going to equal 100 minus that square root divided by 2, which makes negative 3.8516. Woohoo! Okay, so those are gross. Let's hope there's more. Okay. Oh, there is. So, the next ones here all have natural logs, which is nice. This one here can be brought in as an exponent because you never really want to have those little loose parts out front. Of course, 2 to the third is just 8, so we can go ahead and write that as 8. And then anytime that there's a plus going on, that means multiplying. So we're going to rewrite this left side as a 1 multiplication or product of x plus 4 times x minus 3, and that's going to equal the natural log of 8, which is totally a number. So let's see, natural log of 8. A gross number, but still a number. So 2.0794, that's it. Okay, so that means that we're going to solve this by taking e to this part and e to this part, because then we will end up with some nicer pieces. In fact, an 8 again. Okay. And then 8 is going to equal x minus 3 and then x plus 4 being multiplied. So how do we solve this? We are going to factor out this beautiful set of phrases and get x squared plus x minus 12. And then, of course, set it all equal to 0, otherwise we can't solve again. And so we'll have x, oops, what am I writing here? X squared plus x minus 20. Ooh, which is totally factorable, so that's nice. I'm just going to apparently move over here. Because x squared plus x, let's double check that that's it, yep, minus 20 can come from x minus 4, x plus 5. So that means our x's are 4 and negative 5. Oh, that was so much nicer than the previous ones. Alright, so kind of the same process for the next one. Bring up that 2 and realize we actually have log of 8. Also make that addition into multiplication. So just a simplified version of literally what we did in the last problem. So it's technically going to be log base 10 of x minus 2 times x plus 5. And that's going to equal log of 8. If we solve this a little bit by taking 10 to each of these sides, we'll cancel out the 10s and the logs and end up with x minus 2, x plus 5 equal to 8 again. If we expand that expression, we'll get x squared plus 3x minus 10. Or if we move that over, we get x squared plus 3x minus 18. Now we double check if that can be factored. I don't think so. 6 and 3. Oh, yes, it can. No, it can't. Just answering my own questions. Yeah, it can. So, x plus 6 and x minus 3 makes that work. Super, which means our answers are negative 6, excuse me, and 3. Well, that was nice. Okay. So then we get some laws of cooling. Super. So now we have to have that giant formula. So a cup of coffee is cooled from 92 degrees Celsius to 50 degrees Celsius. And right now I'm actually seeing that I'm going to run out of time on this video. So I'm going to do these next 3 on another video. Darn it. Alright, so that was part 1, if you will, of the assignment.